G'day YouTube, JB from Oz again. Tonight's exercise is to model up an adapter for our Sandblaster. We have a port that comes out of the Sandblaster which has an outside diameter of 160mm. We have a dust extractor unit which has a piece of pipe along these kind of lines, and that has an outside diameter of 100mm. So my job here today is to model up a flange to adapt from this 100 OD to this 160 OD with an adapter. So it's called Project You Suck. I use a program called OpenSCAD for a large number of my quick and dirty projects. The reason being is that as a computer programmer I tend to find myself most familiar with projects that I can just code up. So how this works in this instance is I will come up and I will say start OD equals 160mm, end OD equals 100mm. I want to know what my wall thickness will be, so I'm going to put it as 0.62 times 4 maybe? What's that? 6 4 is 24, maybe 5. So about 3mm, but 0.62 is a fairly critical number for my 3D printer. It is the extrusion width that I ask it to use. So 5 times that value means that it will get consistently an appropriate thickness wall. Okay, so I've got a wall thickness, I've got a start OD, I've got an end OD. Let's say I have a transition length, and I want that transition length to be, let's give it 200mm to transition. That gives me a reasonably printable size. And let's say we also want to have a flange length, and that flange length we're going to have probably an inch or so, 30mm, and I'm going to put another function in here which is medfn, which is a functional parameter for how smooth the curves will be. So when I'm designing I set that quite low, and then at the end I can quickly and simply adjust and go to the higher resolution to produce a finer model. Okay. So I'm going to start at one end. I'm going to create a cylinder which is going to have a diameter which is going to be equal to the start OD, and its height is going to be the flange length, and its $FN value, which is its flatness value, is going to equal medfn. Semicolon, render. Oh, didn't like that. What have I failed with? Compilation, cylinder, D, start H equals flange length. Okay, 0.62. Need the equal symbol. Okay, there is a block of object. So I want another one of those copied, which is going to be the start OD plus twice the wall thickness, plus wall thickness times 2. I'm going to put that in brackets just to make sure that the multiplication occurs before the division. Now what I want to do is a difference command, which is the difference of those two objects. Okay. I'll just go to a high-res render. So we're left with a ring. Cool. Alright. That's great. Now I need another one of those. So I'm going to take this, make a copy of it, and my ring is going to be end OD and end OD. Okay. F6. The quick render, which is an F5 command, doesn't handle objects where they finish at exactly the same level. but when you do an F6, which is a finished render, you get a much better render of that. Now, I've got my 2 rings, and I want my second ring to be translated, and I'm going to move it in the Z plane to transition length, let's say. Transition length. So my value there is fairly arbitrarily. Bang. Okay, what happened? Translate 000, transition length, translate thing, transition length. Transition. Okay, helps if I spell the things the same. Okay, now I have an end and a start. Now I want a third one, copy, and I'm going to translate it to my flange length. And F5. So I now have another one which starts at the top edge of the flange, and I want it to finish at the bottom edge of the other flange. So my height, instead of being flange length, is going to be transition length subtract 2 times flange length. So that's going to be for both parts, the inner and the outer. And we'll just do 5. So what's happened there? 2 times flange length? No, just 1 times the flange length, because I want it to finish at the underside of the other flange. Okay, cool. Alright, that's great. However, it's not the right size. So what I'm going to do is change this so that I've got a D2, now adding a D1 equals, and I'm going to put in our start OD plus wall thickness, copy, in our first one, and our start OD, copy, for D1 equals start OD, comma space. Now, look at that. So we've got a cone that fits between the end OD and the start OD. Looks pretty cool. If we do the F6, taking a little bit of extra time, we can see a cone with some transition length on the start and the end. So the start will have 30 millimeters to sit onto the pipe at the Sandblaster end, 30 mils to fit onto the other end. I want my flange length to be a bit longer than that, I think, so I'm going to make it 50. So I'm going to change that one value, 50, recompile, and again, because I'm doing an F6, not an F5, the render does take a little bit longer, but I've now got these longer transitions, these longer flanges, a shorter transition between, but it still looks like a perfectly acceptable shape and output. So really now, I'm happy with my design. I'll just save my design as Sandblaster adapter ring, save, and alright, I've got 20, so 20 is when we talk about net FN, is the number of flat faces that round object is divided up into. So typically when we go to production, we could say, let's make it 200. So F5 quick render, you can see immediately it's quite smooth. That's plenty smooth enough, I think. And then when I do F6, it will just take its time to do that final render. And that should be the end of my modelling for that part. My next step, once that is completed, is to then slice that up ready for 3D printing. But that essentially is a parametric design. So I can now come in later on and say, well, I've got a different adapter I want, which is a different start OD and a different end OD, and I've got a different wall thickness I want, and a different length I want, and a different flange length I want. Rerun the same program, and I'll then have another adapter. And that, for my mind, is the beauty of this parametric programming language for 3D objects. you very much.